Hi dear students, in this section we discuss how to write the equations for voltages in an electrical circuit. That is, here we will learn how to write the equations for the voltages for an electric circuit containing the resistance and the voltage sources, also the inductor, then to solve the current in the circuit. Okay. That is, first we consider a resistor and the current is flowing along this direction. Then I consider the path along this one. Then the equation for the voltage, that is V is equal to I into R. That is, if the current and path are along the same direction, we have to take the voltage as a positive. The next one, the same circuit, it contains a resistor. The current flowing through the circuit is this direction. Then if I take the path that is along the same direction, then here the path and current are in opposite direction. Therefore, this voltage is equal to minus IR. Usually I follow this convention. Now, in the electric circuit, the another component is the voltage source. That is, we represent E. For this battery source, voltage source, this is a battery cell. This is a positive terminal and this is a negative terminal. If I consider the path along this direction in this circuit, then while going from the left to right, first we will see the positive terminal of the battery. Then we have to write this as a plus E. If this is a battery whose terminal is negative and positive, and if your path we consider is around this direction, is from left to right, while coming along this path, first we will see the negative terminal. In such case, we have to write the battery potential, that is E, as a minus E. ഏത് സിമ്പിളാണ് ആദ്യം കാണുന്നത് നോക്കാം. നെഗറ്റീവ് ടെർമിനലാണ് കാണുന്നതെങ്കിൽ ആ പാത്തിൻ്റെ അതേ ഡയറക്ഷനിൽ നെഗറ്റീവ് ടെർമിനലാണ് കാണുന്നതെങ്കിൽ ടേക്ക് ഇറ്റ് ആസ് നെഗറ്റീവ്. ഇങ്ങനെ വരുമ്പോൾ പാത്തിൽ നമ്മൾ ചൂസ് ചെയ്തിരിക്കുന്ന പാത്തിൻ്റെ ഡയറക്ഷനിൽ ഇങ്ങനെ വരുമ്പോൾ നമ്മൾ പോസിറ്റീവ് ടെർമിനലാണ് കാണുന്നതെങ്കിൽ നമുക്കിവിടെ പോസിറ്റീവ് ഇ എന്ന് എഴുതാം. ഓക്കെ. ഇനി അനദർ സർക്യൂട്ട് that is contains a battery cell and the resistance. This is a point A and this is a point B, and this is a current I. This is a battery E, resistance R. Now I consider the path from left to right. Then the potential difference between these two endpoints, that can be written as VA minus VB, because we are going from the left to right, that is from A to B. Then we are taking the potential difference as VA minus VB. The potential difference between these 2 points is equal to, while going along this path, this is the direction of the path, and we first see the positive terminal of the battery. Therefore, we have to write the plus E. Then, while going, we meet the resistance, the resistor R, and the direction of the current and the path, that is, both are along the same direction. Therefore, I have to write this as a plus I into R. Okay. This is In this way, we can write the equation for the voltages. The same problem, that is the direct, this is a battery and this is a resistance. This is a point A, point B. If I take the path opposite direction, this is a direction of the current, this is a voltage source, this is a resistor. The potential difference between the point, I will write VB first, because we are going from the B to A. Therefore, VB minus VA, the potential difference between the two endpoints, is equal to the current is along this direction, the path is along the opposite direction. Therefore, here I have to write minus IR, and while coming to the left, first we will see the battery whose terminal is negative. Therefore, here I will write minus E. VB minus VA is equal to minus IR minus E. Fine. Now, if you have two battery sources, that is the first battery source, I will write this is a E1, then a resistor, then another battery source whose terminal is reversed. This is the point A and this is the point B. The direction of the current is also given, that is from A to B. Now, if I write the polarity of the battery, this is positive and this is negative, this is negative and this is positive. Then I have to write the equation for the voltage. First, we have to consider the path. This is the path I choose. Then the potential difference between the 2 points, that is VA minus VB, that is equal to, while going from A to B, first I see the battery whose terminal is positive. Therefore, I write is a plus E1, and the current is going from A to B. The path and the direction of current both are along the same direction. Therefore, I will write this is a IR. Then, while reaching the second battery, I denote this is as a E2. Then, I see the negative terminal of the battery. Therefore, this should be minus E2. In this way, you can write the equation for the voltage. Fine. Now, I consider another circuit. The circuit contains a battery, a resistance R, and this is a closed circuit. The direction of the current is I. Now, I want to write the equation for the voltage. Then I have to solve the current flowing through the circuit. This current flowing through the circuit is I. Then first I have to choose a path. The path I consider along this direction. Okay. Then now I am going to write the equation for the voltage. The current and the path are along the same direction. Therefore, the voltage developed across this R, that will be equal to plus I into R. Then while going along this path, I see the negative terminal of the battery. Therefore, I will write this is a minus E. There is no other voltage source in the circuit. Therefore, I can write this is equal to 0. Then if I want to find out the current, then we can write IR is equal to E, then I is equal to E by R. Okay. For the same circuit, you can find out the current by choosing the path in the opposite direction. That is, the circuit is the same one. Now I consider the path in the opposite direction. We can write the voltage equation for the voltage now. While going along this path, first I see the positive terminal of the battery. Therefore, this will be plus E. Then the current is towards the left, but the path that we are consider is towards the right. Both are in opposite direction. Therefore, put a minus sign. The voltage developed across R is IR, that is equal to 0. That is, E is equal to I into R, I is equal to E by R. That is, if you check these two equations, both are same. There is a value of the current you can calculate either in this way or in this way. Okay. Now let us do a simple problem. That the problem is this one. Okay, this is the question. That is, we have to calculate the current I that is flowing through the circuit. Now, first we have to decide our path. Usually, I take the direction of the path along the direction of the current. Here the current is flowing in this direction, therefore the path I consider in the same direction. Okay, that is my convention. You can take the reverse also, that is not a problem. Then while starting from this point, your current is going along this direction. Then the voltage developed across the 6 ohm resistor, where the path and direction of the current both are in the same direction. Therefore, I will write this is as a plus I into 6. Then while coming, I see the negative terminal of the battery first. Therefore, this will be minus 4 volt. Then while coming I reached here, I see the negative terminal of the battery again. Therefore, this is a minus 2 volt. Then I'm going, the direction of the current is this direction, and the path that is along the same direction. Here I will take again the positive, that is 3I. There is no other voltage sources or other element in the circuit. Therefore, this is equal to 0. Actually, here we are applying the Kirchoff's voltage law. Then here this 6I, 3I is equal to 9I minus 6 is equal to 0. 9I is equal to 6. I is equal to 6 by 9. This is 2 by 3 ampere. Okay. Now if you have a circuit that has a resistance and an inductor, a volt and a voltage source, then a key is also there. This is a resistance R, inductance L, current flowing through the circuit is small I. This is a positive terminal of the battery, this is negative terminal of the battery. This is nothing but the battery cell. This is a key. Now we have to write the equation for the voltage. Okay, when the key is pressed, a current starts to flow through the circuit. That is, I take this is the direction of the path. Then while going along the path, I see the battery terminal negative first. Therefore, this is a minus E. Then I reached here, the current is around the same as that of the direction of the path. Therefore, the voltage is positive, IR. Then across the inductor, the voltage developed across the inductor is L di by dt. If we just press the key, a current starts to flow, and also if I just open the key or if I break the circuit, at that time also a current there will be a current variation in the circuit. Otherwise the current will be steady. Fine. Now we have to write the voltage across the inductor is plus L di by dt, that is equal to 0. Okay, or if you modify this, you can write E one side, E is equal to IR plus L di by dt. This is the voltage supplied in the circuit that will be distributed along the resistance plus distributed through the inductor also. Okay, thank you very much for watching this video.